Hello everyone, I'm Ryan and I'm here to walk us through how to set up an ACCS RTM simulation linked to a transient thermal. The first step in doing this is to define your engineering data. So just drag and drop engineering data from component systems into the Workbench homepage. Then double click and we'll delete the structural steel material as we won't be using this. And then we'll head into engineering data sources and clicking on Cure Simulation. From Cure Simulation, we'll be taking the RTM fabric and the RTM resin with cure dependent viscosity. Now, if we go back to the home page of the engineering data, we'll see that we have RTM fabric and RTM resin with cure dependent viscosity displayed on the screen. In RTM fabric, there is only one property unique to ACCS, and this is the permeability property. And in RTM resin with cure dependent viscosity, the unique properties to ACCS are the cure kinetic equation and the cure dependent viscosity, and also the thermoset resin properties. The RTM solver supports, in terms of cure kinetic equations, nth order, autocatalytic, and Camosura. If you want more details on these properties, you can refer to the ACCS documentation. We can now close this and drag and drop our transient thermal as well as our ACCS RTM. The model used in this video is the Tutorial 7 model from the ACCS extension. So we can drag and drop our model and then our engineering data onto the transient thermal module, and then drag and drop the model from transient thermal to ACCS RTM. And then we can update. After it's updated, we can double click on the transient thermal to enter mechanical. After we've entered the transient thermal mechanical page, we can press on our geometry to define our fabric. In this case, we'll use RTM fabric. We'll then insert a temperature load and select the body that we wish to apply it to. Now we can define our cure cycle. So in the tabular data on the right, we'll say after 10 seconds or 30 seconds, it'll be 100 degrees. And after 40 seconds, it'll be 120 degrees. After this, we can solve and wait for our result. After the model is solved, we can close it and update our links. Now that the model is updated, we can double click the RTM module to enter mechanical. Once mechanical is open, we will want to define our inlets, outlets, as well as our resin. Let's head into analysis setting and set the resin to the RTM resin with viscosity. And then let's add our inlet and our outlet. We'll use pressure inlets in this case and assign it as one of the faces and with a value of 1000 megapascal. And we'll define the outlet as the opposite face. We'll also want to add our thermal import. We can do this by pressing this button here. If there is only one transient thermal simulation in the project, the thermal import will automatically detect the file needed. Otherwise, you will have to manually define the file yourself. Now let's select the whole geometry body as the target for the thermal import. After this, we should add the results we wish to view. So in this case, let's look at fill. And let's also look at the degree of cure. And then we simply press solve. Once the model has finished solving, we can view our results. Here we can see the fill result and the progression of the fill throughout the model running. We can also see our degree of cure result and the progression of the degree of cure. That's it for today's video. Thank you for watching. In the next tutorial, we'll cover how to combine ACP and the ACCS RTM solver.